Good morning, class. Today we're going to do a lesson. It's in our book, chapter 9, section 5. This lesson will be in 2 parts, or actually 3 parts, and we're starting with just what is a dot product and how to use it to find the angle between 2 vectors. Take a look at this warm-up. Go ahead and try it. Pause while you do so, and then unpause to see the answers. This is just foiling and combining like terms. Don't forget I squared is -1. Okay, next page. Okay, now we're ready to find the dot product of 2 vectors. This is a real number, not a vector, and we're going to use it to find the angle between 2 vectors and also to solve some physics problems. Note when we do the dot product, we use the little dot symbol, which looks like multiplication, but it's different because each vector has 2 parts, an I and a j component. So what you do is you just multiply the I components and you multiply the j components and you add them together and you get a real number. That's your dot product. Remember that the I and j components represent the x direction and the y direction for that vector. So the first thing we're going to do is we have vectors v and w, and we're going to find v dot w. V dot w is going to be -3 times 2 plus 4 times -5. And we end up with -6 minus 20, which is -26. All right, the second one, we thought we'd do w dot w, which is kind of interesting, and you'll see it show up later. So if we're going to do w dot w, that becomes 2 times 2 plus -5 times -5, or 4 plus 25, or 29. Dot product is that easy. Okay, now we will use the dot product to check out some properties of the dot product. Here are a bunch of problems I want you to try finding the dot product for. And then, so pause it here, look at them, try them with vectors u, v, and w, and then when you unpause it, I will show you what you get, and also we'll look at actually some properties. Pause it now. Okay, so in the first problem, right here, note that dot product is commutative, that it doesn't matter which order you do it in. In the next one, it kind of looks like a distribution of the dot product, and that also works. So what was kind of bad about this example, though, is that it equals 0. Even if it doesn't equal 0, it is true. Lastly, if you do a dot product with itself on a vector, you end up finding the square of the magnitude of the vector. And lastly, a dot product with the 0 vector will always equal 0. So now what I can do is I'll just slide down here and you can see those properties written out. Feel free to write these in your notebook. Okay, so now we're going to use the dot product to find the angle between 2 vectors. Note that this theorem is derived using the law of cosines. So we can always find the angle between 2 vectors by using the law of cosines. Just for instance, if you have vector 1 and you know its magnitude and direction, and you have vector 2 and you know its magnitude and direction, you can find the distance between them and then use the law of cosines. So, but now we have this new formula using the dot product. What it says is that if you have 2 non-zero vectors, u and v, and the angle between them is between 0 and 180 degrees or pi, you can find them by using cosine of the angle between them equals the dot product of the two vectors divided by the product of their magnitudes. Let me just slide down here, see if there's any other notes for you. Oh, this is just showing you the proof and also showing you that they took and created a new kind of revision of the formula right here by just multiplying both sides of this formula by the product of the magnitude of u and v. Okay, let's look at an example now on the next slide. Okay, here's an example to find the angle theta between vectors u and v. Note the picture just to give you a feeling as to how it looks. It actually plotted vector u here for -3 and vector v here 2 over 5 up. So the first thing we have to do is do the dot product of the two vectors. So 4 times 2 is 8 plus -3 times 5, -15, and gets -7. Then we're going to find the magnitude of each vector. So the magnitude of u is 4 squared, or the square root of 4 squared plus 9, and you end up with 16 plus 9 or 25, which gets you 5. Likewise, for the magnitude of v, it's the square root of 4 plus 25, which is the square root of 29, and we'll just leave it in simplified radical form. Now we'll write down our formula. The cosine of the angle is the dot product, which is -7, divided by the product of 5 and root 29. When you do that calculation, you'll get -0.26, and then you want to use inverse cosine of -0.26. Make sure you're in degree mode, and you'll get the answer of 105 degrees. What's great about the cosine function is when you take the inverse, you'll be returning angles between 0 and 180. And when you think about two vectors, the farthest, the largest the angle can be between them is 180 degrees. So by using cosine, we don't have to worry about any sort of inverse restrictions to get the angle that we're looking for. On the next slide, you're going to do an example on your own. So once I turn to it, press pause, fill out the example, and then when you unpress, you'll see your answers. Here's the example I'd like you to try. Please note that there's also a nice note at the bottom about, if your angle is acute, look for a positive dot product on top. If the angle is right, look for a 0 dot product. And if the angle is obtuse, then the dot product will be negative. Remember that the dot product is helping you lead towards using the inverse cosine. All right, go ahead and pause it here. Okay, here's the answer. The angle is 161.6 degrees. What was really important about this problem is when you did the dot product, you got a -9. By doing that, I knew that the angle would be obtuse because the dot product was negative, right? If you're taking the cosine or inverse cosine of a negative value, it's going to return an angle in the second quadrant. Another thing we can do with the dot product is quickly see when two vectors are parallel. This theorem says two vectors v and w are parallel if there is a non-zero scalar, or just a multiplier, so that one vector is a multiple of the other vector. In this case, the angle between the two vectors will either be 0 degrees or 180 or pi. It's going to be 0 degrees when they're going in the same direction. It's going to be 180 or pi when they're going in opposite direction. Just kind of see like this. If you have two vectors going in the same direction, like that, then the angle between them is 0. Or if you have two vectors in opposite directions, then the angle between them is 180 degrees. In this instance, instead of getting a 1 for the cosine of theta, you would get a -1 for the cosine of theta. Take a look at the example below. Note that V is 1/2 of W. V is just half of W. So that means those two vectors are parallel. You can also think about it as W is 2 times V. I'm going to pause it here and you can take a look. So now we also have to make sure to check whether any of the other pairs of vectors were parallel. So we've looked at vector V and W and determined that they are. It turns out that U and V are not parallel. There's no non-zero scalar that can multiply times the first one to get the second one. And if those aren't parallel, then we'll find that U and W are not parallel either. So you're just trying to see if there's any value that -2 times, it would be times -3 to get 6. But if you do -6 times -3 or times 3, you get -18. So it has to be the same non-scalar or non-zero scalar on both of the components I and J to see that they're a pure multiple of each other. So the only ones that are parallel are V and W. Okay, this is our last slide for today. So this asks, when are two vectors orthogonal? This is a new term for you. Orthogonal, perpendicular, and normal are all terms that mean meet at a right angle. Remember I talked about the normal vector in our lesson yesterday when we were looking at the gravity or weight problems that use three force vectors? Well, two vectors are considered orthogonal, two lines are considered perpendicular, and if you're intersecting a vector and a plane, then you're considering that to be normal. Really, all three of those terms mean that they form a 90-degree angle. So what we do to determine if two vectors are orthogonal is we're just going to find if the angle between them is 90 degrees or pi over 2 radians. And the formula or the test is, are their dot products 0? If their dot products are 0, then you're going to have the cosine of theta equals 0. And we know that's true when theta is 90 degrees or a right angle. Okay, I'm going to pause it here, check out the example, and see if you can determine if any of the following vectors are orthogonal. First check vector U and V, then check V and W, and lastly check U and W. I will pause it here and you should as well. Okay, here are your answers. Note, so it turns out U dot V is 0, so those two vectors are orthogonal or meet at a 90-degree angle. U dot W equals 0, so those two vectors are orthogonal. And if you remember from the last example, V and W are not orthogonal. They actually end up being parallel. All right, that's it for our lesson. Go ahead and try your homework.